Hi all, welcome to my YouTube channel Easy Coding with Ankit. Today's topic is print both path. Let's get started. So earlier we learned about how to generate board path and then store those board path in array list and return it. Today we will just print those board path. You will see like similar kind of a logic, only few change we will make. We don't have to return it, so we will not store it. We'll just whenever we reach to a last end of the path, then we will print it. So what we will do in case of broadpath, like we discussed, we'll start from 0, then we will try to reach to some specific number. That number will be given. Here you can consider, let's say you wanted to reach 10. So there will be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 12, 10. And how to pick, there will be one dice given. Dice can generate 1, 2, 3, 4, 5, 6. So using dice number only, we can reach to some specific location. So there will be six possibilities. If you are at 0th index, there are six possibility to go. Like you can get 1, then you will go to 1 index 1. If you get 2, then we'll go to 2. If you get 3, then like that it will continue. Let's say if you consider, if you are at 5, then again there will be same scenario. You will get 1, 2, 3. We will add those number with 5 and then try to reach. If you, let's say if you get 1, then we will add 1 into 5, it will become 6, so we'll reach to 6. Same way, you can say these are now some example of reaching 10. If you are reaching, starting from 0, you wanted to reach 10, then if you get 5 times 2, then also you are reaching to 10. If you get 3 times 3 and then 1 time 1, then also you are getting to reach to 10, because if you add it, it will become 10. Then if you get 4 time 2 4 time and uh, 4 2 times and then 2 1 time, then also it become 10. You get 5 2 times, then also you get 10, and then 6 or 4 also is 10. So what is board path? Generate all possible paths on game board from the current position, that is 0, to the end of using the dice rolls. You will be dicing your roll, and then whatever number you will get, you will try to reach to that location. Here you can see the example properly. We will start with 0. With dice we will get 1, 2, 3, 4, 5, 6. If you get 1, then you will reach 1. So to get 10, what else we need to get? We have to get 6 and 3, because we need to collect 9. One is already there, 9. So same way 5 or 4 also 9. 4 times 2 and 1, then also 9. 3 times 3 is also 9. 2 times 4 and 1 time 1 also is 9. Same way 2, if you go, then we have to reach to 8. 6 and 2 is 8. 5 and 3 is 8. Same way 3 also, 6 and 9. 6 and 9 is 7. So we need, in case of 3, we need 7. Like that we will continue it. We will extend this also. If you are at 1, then there are 6 possibilities. That's why the time complexity of generating all the board part is 6 to the power n, because for each option, each selection, there will be 6 other possibilities to go down. So that's the logic. How we'll write it? Here we will just print this path. We will not return it, so we don't have to create any string integer array or string array list. What we will do, we will first we will have our current pointer will be 0, and then int pointer where we exactly wanted to reach. Like in the example we have seen 10, but we will start with 3, so it will be easy how it is, our logic is working. Then we'll create a separate method, public static void. We will not return it, so I'm making it void print board path. Inside that, we have to decide what all parameters we have to take. First one is easy. First we need current parameter, current variable. Then we need int variable also, because based on this only we can see if we are able to reach it or not. And inside this, if you are starting with 0, then there are 6 possibilities. How we will get that 6 possibility? We will create a for loop. For loop int dice, we will roll the dice starting with 0. Dice is less or equal to 6. and then dice plus plus. So with the help of for loop, we can generate six possibilities, and after in each possibility, what we have to do, we will call the same method, print board current. We will pass current and we will pass end. But now we need to change, because now you got the dice. Once you got the dice, we will add that dice into current, because current value is 0, so we need to add the dice, so it will become 1. So from now 1 to 10 we have to generate the path. So that's why, like, it's a recursion call is like, we will call the same method again and again with smaller problem set. At the starting we have value 0 comma 3. Now let's say in the dice first we will get 1, so we will add 0 plus 1, so it will become 1, and end will be same, end will be 3 only, we will not change the end. Now in next call we will execute this method with 1 comma 3, so because we have to generate the 1 3 path, 1 to 3 path. Then one more thing, how we will print it, because here we don't have to store it, we have to print. And printing, what we will do, we create one more variable, string answer, and in that answer you can see we are starting with 0. Once we are starting with 0, we are not using 0, we are not printing 0. We will print only, like, if want 2 times 5, then 2 times 5 will print. We will not print the starting index. So what we will do, we will add answer plus dice. Answer value by default we will keep it as a blank, answer blank, and then blank we will pass here. So once we blank will pass, once we get the dice, that will be added, so it will become 1 only. In next iteration, if you are adding 2, then 2 will be added, 3 will be added, like that. So we don't have to add 0 here. That's why we are keeping answer as a blank, and then dice we are adding. Now we will have some base case. Now we will have some base case. If when exactly we have to end, when current equal to end, that means we have reached to the last location, last number. Let's say if you are starting with 0, then you have reached to 3. If you are reached to 3, then what we will just print whatever value is stored inside answer, because there only we are storing our path, board path. So whatever value we'll get in answer, that will be printed. So starting with 1, then later it will add 2, then later add 3, like that it will add something, some number. And once it is reached this current dice, like this current value will be also changing. So once this current will become 3, then we are printing the path, whatever path we got. We'll have some condition for when current is crossing the end. Let's say if you have current value is 9, then there if you are adding 5, then it is crossing 10. So then we don't need those parts, we don't need to print those parts. So how will handle once current is greater than end? If it is less than, then this for loop should work. This for loop will execute. If it is equal to, then we will print the path. If it is greater than end, then we will just return it from here. We will not do anything. We will not print anything, because those paths will be invalid. We don't have to consider those paths. We will skip that path. So that's about the logic. I've covered all three possibility: when it is equal, when it is greater, and by default it will be less, so it will come. Let's call this method print both paths. We have all three variables. We are passing current equal to 0, end equal to 3, and answer is equal to blank. So you can see I got these four path. First one is, we from 0 we are trying to reach 3, so it is printing 1 1 1, then 1 2, then 2 1, then 3, which is right. If you consider 4 as a end, then let's see how much we are getting. Yeah, 4 time 1, then 2 time 1, and then 2, then 1 2 1, then 1 3, then 2 1 1, then 2 2, then 3 1, then 4, which is also correct. Let's see how this method will work here. First, you're calling this method print bf print method b, and then you're passing what value you are passing. You're passing 0 comma 3 comma blank. That is our first call. It will come in the for loop. How it is executing, that we will trace first. So once it is come under for loop, there are six possibilities. First it will add 0 plus 1, so it will become 1. 3 will be same, and in the answer it will add 1. Same way it will do for others as well. So if the dice value is 2, then it will become 2. Answer will become 2. In the third case, dice value will be 3. Answer will be 3. And fourth case, dice value will be 4. Answer will be 4. So you can see we have this if condition. We can name it as a positive base case, and this one is negative base case. Negative base case, that is like we need to do something, we need to print something or store something. Positive base case is the like main case which we want, where we want to print our board path. So now once the current value is 4, you can see this, it is coming under negative base case where we are returning it, we are not doing anything. So from here you can see it is a negative base case, it will not do anything, it will just print it. But when the current value is 3 and end value is also 3, it is matching, that means it is coming under positive base case. After this after this fourth one, whatever possibilities are there, there are two more possibilities with 5 and 6, and those also will be negative because it is crossing your end. 5 will be again greater than 3 and 6 is also 3. That's why I'm not writing it. You can consider after this whatever will come, that will be coming under negative base case only. So I'm showing just the last one, and before that there is one positive base case because both the values matching, 3 and 3 is matching, and here we will print our path will be 1 comma 3. First we started with uh, not 1, direct 3, we are printing 3 only here. With 2, now we'll start with again 1. If you are reaching 1, there are again 6 possibilities. We can call 1 again. If you are calling 1 again, then current value will become 2. Current value will be 2 and end will be 3. Answer will become 1 1 because we are adding in the string. Then with the same we will call same method with 2, dice value 2, so it will become 3 comma 3 comma 1 2. So that's the second one. Third one, I'm generating till we will reach to negative base case. Here it is equal, that means it's a positive base case. After that it will become 4, like you will get the dice value as, let's say 3. You have already 1, 3 or 1 will become 4, and it is crossing your uh, you're crossing the end value which is 3, so it is reaching to negative base case. Negative base case, that means we will return it, we will not do anything. Here you can see before that it is equal 3 and 3, so it will be coming under positive base case where we will print the value, print what value we will printing, 1 and 2. Again with this also you can see it is less than 3, that means there are other possibilities. We will check this, print bp, we will add one more 1. Let's say we've got one more one, so it will become 3 comma 3, and the answer will be 111. So here also it is coming under base positive base case, and it will print 111. After this, if you go, then you will get negative base case. So I'm not writing it for here. Let's consider 2. With 2 also we'll have multiple possibilities from 1 to 6. So we'll start with 1. 1 if you add, it will become 3 comma 3, and the answer will be 2 and 1. So you can see it is again matching. That means you are reached to positive base case. Positive base case, then it will print answer, whatever answer is stored, 1, 2 and 1. So how many positive base case we got? We got this one. I will just run the code again. So you can see an answer we got triple one. So triple one is coming under base case, positive base case. Then one and two, that is also coming under one positive base case. Then two and one, that is also coming under positive base case, and three is also coming under positive base case. So whenever you will come under positive base case, when that current and equal to end, then that will path will be printed. That's our answer. That's what we are looking for. Time complexity of this algorithm, as I told, for each possibility there are six other possibilities, so it will time complexity will be 6 power n, and space complexity is constant. We are not creating any array list or anything here, so the space complexity is constant. That's about printing the board path using recursion. Thank you for watching my video. If you like the audio, please give a hit and also subscribe my channel.